So in this video I'll be analysing New York City taxi data with Dask. And Dask is a Python module designed to fit the space between in-memory tools like NumPy, Pandas, and distributed tools like Spark and Hadoop. So when data gets a bit too big for one machine, but it's still not massive to justify using Spark, then we can use Dask to increase the scale of comfortable data, from fits in memory to fits on disk. It does this by splitting the input into chunks which are treated in parallel before returning the final result. And I'll be demonstrating Dask using this example from this website. And this is based on data from taxi cab journeys in New York City for 1 year. And the data can be found here. So there's 12 zip files, and I'll be using the files for trips. So I downloaded them here and unzipped them, and we end up with 26.8 gigabytes of data. Now I've written the code here, and I've been running it in Spider, and I've saved the results in this HTML file, which I will go through now. So I start by changing the current directory here, and then I import the Dask data frame module. And Dask data frames allow us to use a lot of the same syntax as Pandas data frames. So here I read the data as a Dask data frame, but actually it doesn't access the data or open any files at this point. It simply creates or registers a sequence of operations that it will need to run later to access the files. So when I run here the head of the data frame, it then accesses the first lines, and we see the output here. So there's some ID numbers, and then there's the time of pickup and the drop-off time, number of passengers, the length of the trip, and the distance, and so on. And then the coordinates of the start and end of the journey. So one way to deal with big data is just to sample a small subset of the data and work with that. And we can do this in Dask using this df sample, and we want 1% of the data here. So we sample the start latitude and longitude, and we do that for 1% of the data. So again, this just stores the sequence of operations to do this, and when we call compute, then it actually does the job, and the result here is stored as a familiar Pandas data frame. So look, and here we've used this progress bar to time how long it takes. So this took 12.5 minutes. And next, we just wanted to plot a scatter plot of these coordinates to get an idea of the location distribution. So I've used Bokeh to do this plot, and I have the plot saved in this HTML file called 1, which I have open here. So we can look at this sample, and here it appears that there's a few points, but actually this blob is a bit bigger, and these are just a few isolated blobs further away. So if we zoom in on this we will see that this is actually this is New York City here, and the other isolated points, they were probably some extremely long journeys that very few people took. So we can see the grid layout of New York City with the park in the middle. So the next thing we do is we want to get rid of these outliers, you could call them, and we do that down here in this number 5. So I've taken the coordinates which enclose New York City area, and I'm subsetting the data further here just to keep the data I'm interested in. Well, I'm subsetting the entire data again, but with these additional conditions. So this time it took 12 minutes and 50 seconds. And again, I've made a scatter plot here, which we can see. I've called it number 2 HTML, and that is saved here. So this is subsetted just on the New York City area. Now, obviously this is one way to deal with big data, is subsetting and looking at a small amount, but it's still taking quite a long time, and this would be a problem if we wanted to do lots of queries with the data and other data analysis. So one way to get an even faster interactive access with the data is to use Castra. And the thing with Castra is it stores the data on disk, but in a smart way. So it uses a binary storage format, and then it stores columns separately. So when you run queries, it only has to deal with the relevant columns instead of the whole data. Another thing it does is it can make use of categorical variables. So for variables of strings where some strings repeat often, you can convert this to a categorical variable which takes up less space. So that's why Castra is good to use. And furthermore, with Dask, you can index. You can set the index to the time, and this leads to even further speed up, because it's much quicker to find things in the data when there's this index based on time. And now I come to a confession that I tried to do this, but did not succeed. There was an error here. So this is expected that it will take quite a long time to create this Castra object, and here it got to 20 minutes, and then something went wrong. But I've tried several times and it didn't work. But anyway, I hope I can illustrate the principle. So it's expected to take quite a long time, maybe an hour to do this. But then once you've created the Castra object, you can do queries on it very fast, even though we had this 28 gigabytes of data. So in Spider, I have some of the code that I wanted to run down here. So I got to this point, creating the Castra object. And then we go back to Dask here. So then, for example, once it's in converted to Castro, we could get the mean number of passengers in just a matter of seconds, 2 or 3 seconds. Another query we can do is take the mean passenger count, but just subset it on the data from April to July. And this takes advantage of the time index that we put on the object. Next, we could repeat the subsetting experiment, but this time it would be a lot quicker and would take around 20 seconds rather than 11 minutes. And finally, we could do more complicated operations, calculate the distance of each journey here, and make a histogram of these distances. And then we could plot this histogram. So this concludes my video on Dask. I hope it gave some impression of the possibilities. Thanks for watching.